So in 15, which of the following scatter plots shows the relationship that is appropriately modeled by the equation ax to the power of b, where a is positive and b is negative? So we see here that this is, some constant times x to a power. So this has to be some kind of exponential equation, right? So we see here that this roughly models some linear equation, and as we just established, this is not linear, this is exponential because, well, it has an exponent. So a is out, and we can also see that, okay, so this is roughly an exponential. You see that sort of, typical curve shape. Here you also see that typical curve shape. In D, this doesn't even really model anything. It looks pretty, pretty random. There's not any clear pattern to this, even though this is a pretty well-defined function. So D is also out. So it's between B and C. How can we figure it out? So A is positive. Okay, that doesn't eliminate either one. But the critical detail here is that B, the actual power, is negative. So if it's a positive power, for example, like x squared or x cubed or something, you're used to seeing that shape where it just curves up like this. But that's not what we see, right? It isn't a positive exponent, it's negative. So from that, we can sort of eliminate C and we get B. But we also just know that when it's a negative exponent, it's called exponential decay. So this is what exponential decay looks like. And the reason it's this way is because, think about it, since you have a negative exponent, that means, for example, if you have x to the negative 2, that's equal to 1 over x squared, right? So the negative exponent just means you got to move it to the denominator. And if you think about that, if this is a negative number, the larger the negative number gets, the faster it'll decrease, right? So for example, if you have, like x to the negative 3, and you keep increasing x, that means that's like 1 over 1, and then 1 over, like, what is that, 2 times 2, 1 over 8, and then so on, 1 over 27. So anyways, from basically just plugging in points directly into this, or just knowing what exponential decay looks like, you can deduce that it is B.